Hello dear students, welcome you all. In this lecture, I am going to discuss about the failures of proton electron theory. Failures of proton electron theory of atomic nucleus. Uh, this article can be, explained in the way that why an electron cannot exist inside the nucleus, right? We have seen in the previous lecture that proton electron theory was an attempt, right, to explain the structure of atomic nucleus, right? And the main thing that is the basis for this theory was the beta decay, right? Emission of electrons or positrons from an atomic nucleus, right? So although this theory was capable of explaining beta decay process, or we can say emission of an electron from the heavy atomic nuclei, but there were several objections on this theory, right? So in this lecture, I am going to discuss all these objections one by one. Because of all these objections, this theory was very soon discarded and it was replaced by proton neutron theory, right? In this lecture, we will start with the different objections that are, going against this proton electron theory of atomic nucleus. We know very well, if I talk about the atomic nucleus according to proton electron theory, let this is the atomic nucleus. Now I am just considering the atomic nucleus, I am not considering the atom, right? Let this is atomic nucleus. Then according to proton electron theory, this atomic nucleus consists of protons, positively charged protons, right, and negatively charged electrons are also present there, right? These are negatively charged electrons. They are also present inside the nucleus according to this proton electron theory, right? We have seen it in the earlier lecture, right? So this now, and according to this theory, if I have a nucleus that is represented as Zx a, here a Z is the atomic number, A is the mass number, then this nucleus contains A protons plus A minus Z electrons, whereas Z extra electrons are revolving around the nucleus, right, in order to make the atom as a whole neutral, right? So if I take an example, for example, 7 nitrogen 14 nuclei, right? So according to this theory, there will be 14 proton plus 7 electrons inside the nucleus, right? You can say, whereas 7 electrons are also revolving around the nucleus, right? So this is about the proton electron theory. Now I am coming to the different objections, right? The first objection was wave mechanical consideration, right? Wave mechanical consideration. This is the first objection. Suppose electron is present inside the nucleus, and let the diameter of the nucleus, this is nucleus, its diameter is R, right? We know r is of the order of 10 raised to power minus 14 to minus 15 meter. So then its diameter will be, if radius is r, then diameter will be 2 into, diameter is equal to 2 into 10 raised to power minus 14 meter, right? Now, if the electron is present inside the nucleus, then the uncertainty delta x in its position should be nearly of the order of 2 into 10 raised to power minus 14 meter, right? This is the minimum value of the uncertainty, right? Here 2 into 10 raised to power minus 14 meter is the diameter. Now, according to uncertainty principle, we know very well delta x into delta p should be nearly equal to h cut, right? We can say it should be greater than equal to h upon 2 pi. So now if I look at the value of delta p, uncertainty in the momentum according to this relation, then it should be equal to h cut upon delta x, right? So if I put the value of delta x here, right, then I will get uncertainty in its momentum nearly equal to h cut means 1.05 into 10 raised to power minus 34 joule second divided by delta x means 2 into 10 raised to power minus 14 meter, right? So when I solve it, I will get delta p nearly equal to 0.527 into 10 raised to power minus 20 joule second, right, per meter. Now, this is the value of uncertainty in the momentum of the electron when it is present inside the nucleus. Means this is the minimum value of the momentum of the electron. Now, if I consider the momentum energy relation, E is equal to P square C square plus m naught square C power 4, right, under the root, then I can use this value, momentum value here, because I am considering that this is the minimum value of the momentum that electron should possess if it is present inside the nucleus. It is present here, right, inside the nucleus. So in this case, now we can put this value here, we can put the value of C. Here m naught C, m naught square C power 4 is basically what? It is the square of m naught C square square. What is m naught C square? It is the rest mass energy of electron. Now we know very well what is the rest mass energy of electron. It is 0.51 mega electron volt. So if I put this value here and compare with this value, then we found that this value, rest mass energy, is very small, right, as compared to this term, right? So I can ignore this energy here. So I can say E should be nearly equal to P C, right, if I take only the positive sign, right? So now I'm going to put the value of P, that is 0.527 into 10 raised to power minus 20 into 3 into 10 raised to power 8, right? It should be equal to in joule, right? So when I simplify this, I will get, and I convert it into electron volt, then I got of the order of 10 mega electron volt, right? Now here we found the energy of the electron should be nearly equal to 10 mega electron volt. So when the electron came out of nucleus in beta decay, right, in beta decay we know electron are coming out of the atomic nucleus. So when the electron is coming out of atomic nucleus, its energy should be nearly equal to this energy. But when the experimental observations were made, it was found that the energy of the electron was nearly equal to 3 to 4 mega electron volt, right? So there is lot of difference between the theoretical prediction of the energy of the electron, whereas the actual energy absorbed when electron is coming out of the heavy nucleus. So it means the possibility of the existence of the electron inside the nucleus is very rare. because the energy equations are not matching with these predictions, this proton electron theory predictions, right? So this is the first objection, right? Now I am coming to the second objection. Now the second objection is related to the nuclear spin, right? It has been observed experimentally after the study of different nuclei that the spin, nuclear spin of even nuclei, or we can say even nuclei that has A is equal to even and A is equal to odd. Two possibilities are there. So according to different experimental observation, it is found that the even nuclei have integral or zero spin, right? Whereas odd A nuclei have a half integral spin, right? This is the experimentally observed fact, right? Now if I apply this um, this yes, this model of proton electron theory, this model here, then I can say if a nucleus, for example 7 nitrogen 14, now it is obviously A is even, so its uh, spin, nuclear spin should be either 0 or a integral, right? So let's see what is the prediction of a proton electron theory, right? Now we know very well that both electron as well as a proton, they are fermions, they have a half integral spin, right? So if they have half integral spin, then I can see here what is going to happen. 14 protons plus 7 electrons in the nucleus means total 21 particles, 21 fermions. So the total spin of the 21 fermions will be half integral multiple of half integral multiple of h cut, right? So according to proton electron theory, the nuclear spin of this nucleus should be half integral. But when experimental observations were made, then it was found that the total spin of the nucleus of 7 nitrogen 14 is even. Oh, sorry, it is a integral, right? So what does it mean? It means that this proton electron theory is making totally wrong predictions of the nuclear spin of different nuclei, right? So this is the second objection, right? And according to this objection, now it is proved that electron cannot exist inside the nucleus. Otherwise, there is a violation of this established experimental fact, that is this, right? That even A nuclei have integral or zero spin, odd A nuclei have half integral spin, right? Now, I am coming to the third objection. Third objection is a nuclear magnetic dipole moment. Now we know that the dipole moments of although we will discuss in details about the magnetic dipole moment of atomic nucleus in detail, but here I'm just considering that we calculate the or we measure the magnetic dipole moment of the nuclei in terms of nuclear Bohr magneton. Magneton. Bohr magneton or nuclear Bohr magneton is the natural unit for the measurement of magnetic dipole moment of atomic nuclei, and it is equal to E h cut upon 2mp, right? And this is the unit for the measurement of a magnetic dipole moment of atomic nucleus. This is called nuclear Bohr magneton. In case of electron, we have electronic Bohr magneton for measuring the magnetic dipole moment of electron, and that is equal to E h cut upon 2me. Now you can see these two factors, right? Here it is mass of electron and here you have a mass of a proton. We know very well that the mass of electron is nearly 2000 times, or we can say mass of proton is nearly 2000 times greater than mass of electron, right? So you can see here that if the mass of proton is greater than 2000 times mass of electron, it means this nuclear Bohr magneton, right? This term is very small. I can say mu n and I can say mu e. So I can say mu n is very less than mu e, right? It means that the total magnetic dipole moment of the atomic nucleus should be of the order of this factor, right? Or simply saying means that the electronic Bohr magneton or electronic magnetic dipole moment, right? The magnetic dipole moment of electron should dominate in the nucleus, because the magnetic dipole moment of the proton is nearly 2000 times less. But when experimental observations were made for the measurement of nuclear magnetic dipole moment, it was found that the actual magnetic dipole moment of the nucleus, that I am writing now capital U n, it was very less as compared to electronic Bohr magneton, right? It was rather of the order of this nuclear Bohr magneton, right? So it means if the magnetic dipole moment is not of the order of this, it should be of the order of this, because it has highest contribution. So it means now the electron is not present there inside the nucleus. Otherwise the magnetic dipole moment should be of its order, right? So this is again a very serious objection on the proton electron theory, or the existence of the proton electron inside the nucleus, right? Now I am coming to the next objection, objection number 4, right? It is wavelength of electron. We know, according to the de Broglie hypothesis, lambda is equal to h upon p. Here h is Planck's constant and p is the momentum of the particle. So we have seen that p is equal to h cut upon 2 delta r. We have seen here, right? Delta x, it was 2r, right? So now I can put the values here. So lambda is equal to h upon h cut upon 2 delta r. So it gives me, it was not h cut, it was h here. It is wrong. I should correct it. H upon, right. So I can say h upon, again I wrote h cut, h upon h upon, or I can say into 2 delta r, 2 into 2 pi divided by h. Oh, I have already written h here. So now what it becomes? 4 pi delta r. So it means the wavelength of the electron should be of the order of 4 pi delta r. What is delta r? It is 4 pi into 10 raised to power minus 14 meter. Now you can see here that the wavelength of the electron, if it is present inside the nucleus, should be of the order of this. So obviously wavelength is greater than the radius of the atomic nucleus, 10 raised to power minus 14 meter. So how it is possible? how electron can exist inside the nucleus. Even its wavelength is getting larger than the dimensions of the nucleus. It means wavelength means if I have this wave, then wavelength means this distance. If this distance is greater than this, so how electron can exist here inside the nucleus, right? Because its dimensions are small as compared to the wavelength. So it is again proving that it is impossible for the electron to stay inside the nucleus, right? Now there is one more objection that is left, that is finite size of electron. Size of electron. So this last objection says that if electron has a finite size, finite dimensions, right? So when we approach the heavy nuclei, right? So in those nuclei, as the number of protons are increasing, obviously number of electrons are also increasing. So it will become very difficult for the nucleus to accommodate these large number of protons and electrons, because the size of the nucleus become very large, and we know the nuclear forces saturate at the distance of 10 raised to power minus 15 meter. They can't handle the size more than 10 raised to power minus 15 to minus 14 meter, right? So it means if large number of electrons are present inside the nucleus, size will be large, and then stability of the nucleus will decrease. It means nucleus won't be stable, it won't exist in that state. So these are the all objections against the proton electron theory, right? Starting from the objection of total energy that is derived by using Heisenberg uncertainty principle, then nuclear spin, then nuclear magnetic dipole moment, right? Then wavelength of the electron, and then size of the electron. So all these things are going against proton electron theory. So due to all these reasons, the proton electron theory was discarded, right? It was discarded, and it was proved that electron cannot exist inside the nucleus, right? So then after there was a discovery of neutron, and we have a proton neutron theory that we will discuss in the coming lecture, right? So thank you very much.